All right, so we'll talk about quantum numbers and how they relate to each element in atom. Each atom will have its own unique quantum numbers, which serves as basically the address. And we will do the quantum numbers for the last electron in the electron configuration. For our quantum numbers, we have 4 quantum numbers: the principal quantum number, angular, magnetic, and spin. So for our quantum numbers, we are going to have principal quantum number. This will relate to the size of the orbital, and then indirectly it will describe the energy of the orbital. So for the principal quantum number, we're looking at the energy. This is what we talked about before: n equals 1, n equals 2, n equals 3. How far are we away from the nucleus? How much energy does it have? The second quantum number is the angular quantum number, or L. It's going to describe the shape of the orbital. So it will be the same as S, P, D, and F. It can include anything that's 1 less than whatever n is. So if n equals 1, then it only has 0. Or if n equals 2, then it has 0 and 1. And so we look at these orbitals. So S will equal 0, P will equal 1, D will equal 2, and F will equal 3. All right, the third quantum number is going to be the magnetic quantum number, and this will describe it says the orientation of the particular orbital. This essentially says which orbital would the electron be in inside of the subshell. And so we'll have some integer between -L and +L. So whatever the number is from the angular quantum number, it will be plus or minus that. And I'll show that to you on the next slide. For these 3 numbers, these first ones, these ones specify the orbital that the electron is found in. The last one will tell you specifically which electron it is. So inside of each orbital, it can be 2 electrons. So the last quantum number tells you if it's spin up or spin down or spin clockwise or counterclockwise. And so we use the value of +½ or -½ Okay, so for our magnetic quantum number, whenever we're looking at this, we're talking about where do the electrons fall. So this S, P, D, and F, this would be the angular quantum number. So this is the second one. And we would call this 0, 1, 2, or 3. For the specific orbitals, we're just kind of drawing our orbital boxes and designating which one would be -1. So for P, -1, 0, and +1. So if I have some electron configuration where the electron ends like this, then the magnetic quantum number would be 0. And so it tells us which orbital the electron is found in so that we can be very specific and we know how many orbitals we have. Now for the spin, I typically do +½ for the first electron that goes in and then -½ for the second one. Just to show the spin up and spin down. So let's do a few examples. So sodium is going to be our first example. And whenever we look at sodium and we're trying to determine which electron we're looking at, we are designating this electron. So for our first quantum number, which is going to be our principal quantum number, or n, our first one will be 3. So this is telling us our principal energy level. All right, our second one, which we designate L, is going to tell us which sublevel it's in. So we are in the S subshell, so that's going to be 0. So this tells us our subshell, where S equals 0, P equals 1, D equals 2, F equals 3. All right, our third one then is which orbital will it be in? Well, in this case, you can't have any other orbitals. So S is always going to have only one orbital, which is going to be 0. So if it's S for the angular momentum, or the L, and we have 0 there, then M will also be 0 because there's only one orbital in which we can fill it. All right, our last one then is going to be our spin. And so our spin will be S, or sometimes you'll see it as, I believe, MS. Now, for sodium, we would have 1 electron going up, so I would call this +½ And so the quantum numbers for sodium would be 3, 0, 0, +½ All right, let's try for sulfur. So for sulfur, we are looking at the electrons 3p4. So the electron that we are analyzing or giving the address for is 3p4. So our first quantum number is N. This is telling us our principal energy level, which is 3. Our second one is the angular. This is telling us our L. This is looking at which subshell is it, which is P, and P will always be 1. Our magnetic one will be P, so it can be positive 1. Oh, sorry, should probably do it. So -1, 0, positive 1, okay? And so whenever we look at this, we're saying which orbital does the electron occupy. So I'll fill in those 4 electrons, 1, 2, 3, 4. And so specifically, whenever we're looking at this electron, we are looking at that last electron that we put in. And so our magnetic would be -1, and then our spin would be, because it's down, -0.5. So the quantum numbers would be 3, 1, -1, -0.5. Okay, so let's do another one together. So we are looking at 3d3. So our first quantum number is our principal energy level, which is 3. Our second is our angular, which is what's the subshell, so D is going to be 2. For our magnetic, we have D, which will be -2, -1, 0, +1, +2, and we have 3 electrons, so 1, 2, 3. So our magnetic quantum number would be 0. And then our spin would be, there's only 1 electron in there, and so it would be +0.5. So our quantum numbers for this would be 3, 2, 0, and +0.5. All right, let me give you some other examples, and this will come from your practice problems. So we'll do aluminum first. Why don't you go ahead and give it a try, pause the video, and then you can check your answers. So we have aluminum. Our first one will be N is 3. This relates to our principal energy level. L will relate to our orbital, which will be 1, P equals 1. M is going to be which subshell is it found in. So we have 1 electron, so this will be -1 because we have -1, 0, +1 for P. And then our spin, it only includes 1 electron, and so it'll be +1/2. All right, for giving the element and the electron configuration for each of the following, so we're going to go ahead and work backwards. And so we have 3, so this will be principal energy level number 3, so principal 3. And in the third row, we have 2, so we know that this is a D subshell. And we have a 1, which means that if we look at our D sublevel, so we have -2, -1, +1, +2. So the electron is going to be found in here, and then it's -0.5, meaning that we would have to have that full like that. In order to have that doubled up as the last electron, you would have to have the rest of these orbitals full. And so we would say that this would be D9. So it would be 3D9, which would be the last orbital, the last orbital that's filled. If 3D9 is the last electron, then this means that this element is going to be copper. All right, so why don't you do the 2 other examples, pause the video, and then check back in to check your answers. So for calcium, we'll have N equals 4. L is 0, which means that M also has to be 0. It's the second electron, so it'll be -1/2. For the bottom one, we have 6, so this is the 6th row. 0 indicates S. This indicates that it's in the only orbital that S has, and then +1/2 means that there's 1 electron in the orbital, meaning that we would have 6s1, which would be cesium.